So now we are given two similar problems, but the difference in these problems are, the difference is, from the first question, it's asking the number of molecules of their entire molecule, while in the second question, it's asking the number of molecules or atoms of the specific atom located inside the molecule. Okay, it's two different things, and I'm going to explain you why they are different. Let's start from the first one. So we are given sodium sulfate, so the same procedure, and it is 1.3 mole. So what we have to find how many molecules of sodium sulfate. So we're going to write again sodium sulfate, and so how many moles. So see here, if it's asking how many moles, how many molecules, or I'm sorry, not how many moles, how many molecules, how many atoms, the number of atoms, the number of, so whenever you see the number or how many, know that it's related to an Avogadro, the Avogadro's number. Okay, if it's asking moles, how many moles, then it's just a mole, which will have only one on the bottom. Like here, you have to find the X number of molecules. Okay. If you have no idea what's going on here, go ahead and watch my other videos. I explain it more in details of setting up this equation and about proportion and cross multiplication. Okay. So here in the left side we have 1.3 moles, which means we have 1 mole in the bottom. It's a standard condition, and since we have to find the number of molecules on the top, we're gonna write 6.02 times 10 to the 23, which is Avogadro's number. So that's it. All we have to do is just to do a cross multiplication. So 1.3 times 6.02 times 23 divided by 1, which will give you x. So we're basically solving for x. So x is equal to 1.3 times 6.02 times the 23 divided by 1 mole will be equal to 7.83 times 10 to the 23. So that's the number of molecules of sodium sulfate present in sodium sulfate molecule. So now the second question, it is asking you to find the number of atoms of sodium which is in the sodium sulfate. So again, we're going to start from the same procedure, just what we're given to us. We're given sodium sulfate, and it is 1.3 moles. So we're going to put the arrow. So what we have to find? So we have to find sodium. So now it's not sodium molecule. It's not the molecule of sodium sulfate. So it is that sodium atom. Okay. So what we have to find? Okay, we have to find the number of molecules or atoms. Okay, so x the number of. So now you see here, this is not balanced reaction. What do you mean balanced reaction? So here, if you notice that you have 2 atoms of sodium on the left, but you don't have 2 atoms of sodium on the right, so you have only 1, which means you should put 2 as a coefficient. And as I mentioned in my previous video, you can't put that 2 right here. It's not inappropriate, so you have to put it right before the atom, and we call it coefficient. Okay, so now the reaction is balanced. and all we have to do is just to find what we're going to do right in the bottom, which is going to be in a normal condition. So on the left side we just write 1 mole. On the right side, and since the number of atoms is on the top, on the bottom it's going to be again the Avogadro's number, 0.62 times 10 to the 23. But since we have two coefficients, we have two sodium, we're just going to multiply the Avogadro's number by 2. So yeah, that's it. We set up our equation, our proportion, and all we have to do is just to make a cross multiplication and solve for x. So to solve for x, again, 1.3 times 2 times 6.02 times the 23 divided by 1. So 1.3 times 2 times 0.2 times 10 to the 23 divided by 1, which will give us 1.56 times 10 to the 24. So this is the number of atoms of sodium present in sodium sulfate molecule. If you have any question, let me know. In my future video, I will upload more about stoichiometry and how to make a balanced equation and how to solve for grams, moles, and molecules when you have a long reactions, when you have a long unbalanced reactions. Okay. Thank you.